Today I want to introduce the last of the new stuff. It isn't really new, but it's something I've had in the program, but I haven't actually talked about it at all. It turned out when they started doing 3D graphics, what they did was they made characters and things by making a bunch of points, and then they connected those points together and made planes out of the points. So basically, in order to describe any object, no matter what it was, they had to have a bunch of points, X, Y, Z points, told what the shape of the object was. Well, after they did that for a little bit, somebody got the bright idea, well, instead of just having a bunch of points, what if each point was a picture or something? So in other words, it's sort of, instead of connecting together and making a character, like a whole character like that, what if you took each point and you made it into a little picture like that? Because you already know where they are. And so what you do is you just simply put a picture at each one of those points, okay? And they invented the idea of a sprite. It's called a sprite. And they also it's called particle. These aren't quite the same, but for our purposes, they're the same. The sprite and a particle. But basically what happened was they said, well, since we have to keep track of points, what if we just keep track of points and we call each one of them an individual thing? And then what you could have is you could have a whole cloud of images, a whole bunch of images. In fact, in our machines, just to show you how good this works, I created one just for fun with 50,000 sprites in it, and it worked. It ran perfectly smooth, and it was amazing. And my machine's not that great. So you can put lots of them in. I mean, you can put lots and lots of these sprites in. So the question is, what do you get though? What are we doing that was different than what we've been doing already, instead of making characters and putting texture on them and all that? Well, what we're doing is, the first thing they did when they invented the sprite, they got this very bright idea. They said, never let the sprite face away from the camera. Always face the camera. So if it had a little, plus on it or something, whatever you draw on it, it can have any pictures you want. If I go over here, they'll all face me. If I go over here, they'll all face me. They'll never turn away from me. Now, that might seem like a really weird idea, but if you were, for example, building a forest, suppose you were doing some kind of animation, and you had a bunch of trees here. This is a tree, believe it or not. And what happens is, you have a choice. If you make a three-dimensional tree, you can do that. But if you make a three-dimensional tree, you're going to have to build points for the tree. Then you have to build points for the other trees. Lots and lots of points, and that's the trouble. It takes a lot of calculation to get to put those points in. So what they said is, why don't we do this? We'll make a sprite that has a tree printed on it, so it's a little image of a tree. And then what happens is, as you move around in the real world, the tree will always face you, so it'll look like it's still a tree no matter which way you go. It won't turn into a flat object. In other words, you won't go behind it and say, oh, that's just a flat picture. As long as it faces you, it looks the same all the time, but unless you're looking right at it, just studying the thing, you wouldn't notice that. So they made a bunch of sprites that pointed at you all the time and allowed you to give you the impression that when you move around, everything was still the same. Nothing turned flat. Everything was still looking at you. And that turned out to be a very, very handy thing. And so that's what we're into today, is the idea of the sprite. When you make sprites in our program, I'm going to write down the instruction for doing it. There's a specific way of doing it that it's special for our program, our system of programming. What I have to do is, in order to do this stuff, I have to think about what you use stuff for and try to figure out if I can give you every possibility or not. We don't have every possibility of sprites, so we only have a limited way of using them. But I limit it in a way that's useful. I could have limited it so that it would be complicated, you wouldn't get as much out of it. But this one is simple, and it does give you everything you want. Basically, here's what we have. If you want to suppose you want to make a field of sprites from anywhere from 1 character to 10,000, you can do that with one simple line, one simple instruction line. Here's what it looks like. It's a script line. This is just like all the script lines we've been using so far. And this one says variable. Then you got to give it a name. Give a name to your object, whatever it is. And I'm going to call mine my sprite. How about that? My sprite. This is my name right here. You give it a name that whatever name you want to give it. And it equals new. And the word I used was, oh, unfortunately, my sprites is the name of the thing, the function. Okay, and then I put, I'll put in 50, comma, 500, 500, comma, 500, 20, comma, banana. Like that. Okay, there it is right there. That's the line that creates a sprite for you. That's the line that, just like any, that creates a plane, creates a donut, whatever. This one that creates a sprites for you. And here's what these numbers do. This number right here, the first number says, how many sprites do you want? Okay, you can, let's say I went up to 50,000. You can make as many as you want, basically. Until your machine starts going, and starts slowing down. This right here, these three numbers right here are X, Y, and Z. Let me tell you what they do. What they tell you is, you want to have your sprites distributed. You know, it's going to randomly put them into a box. You want them distributed so that between minus 250 and plus 250. I said 500, so therefore that's 250 this way and minus 250 this way. It will put them randomly somewhere between those two numbers. So in other words, in the X direction, your sprite will be generated randomly. They'll be generated, and uniformly randomly, and it will appear somewhere in that space right there. So in other words, the first sprite will be put there, then the second one will be put there, and you find them all over in different places, different positions. Okay, that's what this thing does. It randomly creates the number of sprites you want in that range. And in the Y range, the same thing. If it's 500, so it's minus 250 this way, and plus 250 that way, it creates equally distributed this way too. So in other words, your sprites now appear on a plane randomly between 250 and minus 250, X and Y, okay? Then what you do is you do it in the Z direction. You can pick any numbers you want, by the way. I'm picking 500, but you can pick any numbers you want. All it would simply do, instead of 250, if you put down 10, it would just go from minus 10 to plus 10. That's all it would do. So in other words, what it does is it basically, minus 5 to plus 5, sorry. It goes half the number that you want. So what this simply does is says, I want 50 random replaced sprites somewhere between minus 250 and plus 250 in the X, minus 250 and plus 250 in the Y, and minus 250 and plus 250 in the Z. You can put any numbers in here you want, okay? And finally, this thing is the size of the sprite. The sprites have different sizes. Telling you what the size means is out of this world difficult to do. The best way to do it is put in a number, look at it, looks like if it isn't the right size for you, just make it smaller. Usually they seem to be about, by the way, the maximum is 64, I do know that. It's all in the implementation of this stuff. In different languages they do it differently, but in our language they do it 64 seems to be the max. Because if I make it bigger than that, it doesn't seem to get any bigger. So I think that's it. Usually the sprites I've been using somewhere between 5 and 20. That's about the range, like I made snowflakes and stuff like that, and that's about the place to put them. A sprite is a texture. It's a texture map, basically. And if it's a ping file, it can have transparent texture. So if you want to make a snowflake, for example, here's how I did it. They're the simplest ones of all. I went into a paint program, and I made this all black here. Then I put in one little white spot, which was the snowflake. And then I went to X and View, and I made this thing right here transparent. So I ended up with just this, and this transparency around it. So in other words, you can't see that, it's invisible. If I just put that into a sprite, it actually would work in our system, but it wouldn't work in regular systems. You have to tell it to be transparent. You have to say, make the transparent part transparent. Or what you just get is a dot with a black area around it. That's what happens. Now it turns out we have a little problem with sprites. They have their own technical difficulties. Transparency is the problem. Now, you need transparency in order to get the object floating. If you put a transparent sprite against a background, it works perfectly well. So for example, if you go to any of the programs I have there, or I have some kind of background like this, and I put a sprite in front of it, this thing right here does not show up, and all you see is the object that you've drawn, the one that you want them to see. That's all you see if it's against the background. The trouble comes in when one sprite gets in front of another one. So if you have one sprite here, and another one comes in behind it right here, like so. That's when you get in trouble with this, with all of these systems. They all work like, they all have this problem, by the way. when you draw stuff in a computer, when the computer draws stuff, you don't know this, it happens, but they use what they call a painter's algorithm. It's always done the same way. What they draw is they draw the backmost thing, and then they draw the object that's closer to the Z, and then the object is closer, and the object is closer. And the reason for that's very logical. If you draw the backmost thing right here, when you draw the next forward thing and it gets in front of it, it'll draw right over it. So there will be, it'll look correct, okay? If they drew in the other direction, it would be completely stupid, because then what would happen is, if they started in the front and went to the back, what would happen is they draw the front one, and then when they draw the back one, it would go right over the front one. It would draw like that. So in other words, it would be crazy. It wouldn't work right. So basically, the computer itself looks at every object and it starts drawing it from the back, and it goes to the front like this. Except for sprites. Sprites have a really big problem. Sprites are drawn in a different pass by the computer. And what they do is they draw them according to their initial position, where they were originally when they started it. I guess that's the way they do it. That's my assumption. And then what happens is if you take two sprites that were drawn normally like this and you put them like that, it screws everything up. All of a sudden the black spot appears, the black area appears a little bit. So what happens with the sprites, the trouble with the sprites is when you make an object and you make a transparency around it like that, this is all transparent in here, and this thing happens to get in front of something that previously was behind it, then all of a sudden you can see through it. You can't see through it anymore. It's black. Okay? It's a little bit irritating, but if you keep the black space small, like for example, you draw an object and you make the black space around it very, very small, then there's no problem. Actually, if you can push it right up to the edge of it, it'd be perfect. Then it's such a small black area, it doesn't hurt anything. But if you make a transparency that's got a snowflake like that and a big transparency over here, then you're going to have trouble. It's going to cause you a problem, okay? So my suggestion is to keep the transparent area as close as you can to the object you want them to see. So if you have a little character, for example, of some kind, and you want the character to be seen clearly, and the sprite is this big originally, well, cut it down to right here, and have that, and then just make invisible just the area right close to them, that's all. And that'll help quite a bit. That's my suggestion, okay? Okay, here's the next thing. When you have sprites, you assume you're going to make lots of them. Sometimes they use them to make waterfalls, or rain falling, or they use it for anything that happens, lots of it happens. Or if you can make smoke with them, you can do anything. Actually, it's quite good. But the trouble is, the format we're using right here is the simplest possible way to get them to you. Otherwise, I would have had to give you a lot of instructions, and I didn't want to do that. What this one does is it just gives you the basics. It says, I want 50 of them. I want them to be within these boundaries, minus 250 to plus 250. You can use any numbers you want in here, by the way. It's just this form you have to use. And I want them to be some size around under 64, but whatever, and have a picture on them. So therefore, those are the only things that you have to write. You don't have to worry about anything else. Behind the scenes, what's happening is a bunch of stuff, but don't worry about it right now. Each sprite can be addressed. You can say to the sprite go over here, sprite go over there. Sprite, you can't tell them to turn because they won't turn. They refuse to rotate, okay? But they will move. You can move them around different places. So sprites do have an individual thing as far as positioning them. You can do that. We're not doing it simply because we don't have access to each sprite. But here, what you say is make 50 of them. So right away, we don't have a sprite. We have 50 of them. And whatever we do is going to happen to all 50. It's like it's an object. All 50 of them are going to be moving that direction. So if you build a field of sprites like this, yeah, you can go around it, look behind it, you can do everything you want, but this is considered like an object. It's an object that you're working around, okay? Each individual sprite is just a point in that object and you can't control it. If you make only one sprite, you can, because that's the only one. And the object in the whole cloud of objects is only one object. So you can do that. If you only want to make one sprite, you can. One of the programs I'll show you today is it's got a UAV, unmanned aerial, one of those little machines that fly around. And what happens is that's one sprite. I just made that one character. That's all. And then what I did is I had it doing stuff. So let me explain how you do that. In other words, you can't control a single sprite, but you control the whole field of sprites. Okay. So in this particular case, let me redraw this a bit here. In this particular case, I made this UAV, and it's basically looks like this, something like that. It's got propellers on it, a couple of legs. That's what it looks like. And it's only one sprite. I only wanted one sprite, okay? So what I did was, let me get my thing here to make I got the right thing, yeah. So what I did was, in these numbers over here, here's what I put in the numbers. I wrote the numbers, my sprites, just like I did there. I want to write the same ones though, because I want to show you what happens. My sprites, 1 because I only want one sprite. So I said I want one sprite, not 50, just one. And then I put it in this range. I put it in 200, comma, 10, comma, 200. What I wanted it to do was, this is the X direction, and this is the Z direction. I wanted it to be placed somewhere like that, okay, but I didn't want it to be up and down. I wanted it to be right at eye level. So I put it at 10, which is about eye level where the viewer was, about 10. So it's going to be generated up somewhere between +5 and -5. It's going to be right in there someplace. And it's going to be somewhere, this one here is 200, so it's going to be negative 100 to positive 100. It's going to be negative 100 to positive 100. So when you actually look at this thing, the center of its world is right here. That's the center of the sprite world right there. And it's going to go minus, in the X direction, it's going to go minus 100, and it's going to go plus 100 in this direction. And it's going in the Y direction, it's only going to go 10. It's only going to go 5 to -5 right here. And in the Z direction, it's going to go 100 to -100. So in other words, along this flat plane right here, where this is flattened out, it's going to be generated somewhere randomly in that area. And that's because I didn't have any specific place I wanted the thing to be. I just said, okay, just put it out there. Be sure it's in front of us. I don't want it to be off in, Timbuktu someplace. And I wanted it not to be too high and too low, so I just made that 10 very narrow. So that's what it did. And I made the thing, I think it was 50. This was a pretty big one, if I'm not mistaken. Yeah, 50. Because it had a lot of stuff on it. It had the propellers and the thing and everything. I wanted to get everything in. So I made it 50 tall so you can actually see the stuff. You can actually see what's going on. And then I don't know what I called it, the UAV ping or something like that. Something like that, whatever. You can see on the program. And there it is. That's the one that says, new, like that. And variable, W, whatever. Anyway, this is what the thing looked like. And that right there is the stuff I used to get just as one character. You can bring this stuff down, that 200 right there, you can bring it into a marginal space. I think you can put it as low as a 1 in here. I'd put it in a 2 at the least. If 1 doesn't work, if it doesn't give you anything, put it in a 2. So I put it in a 2 in these places like that. If you did that, what would happen is the sprite would go randomly into a very small space. And then it's almost in one spot. If you put down the lowest number you can put, it'll go in one spot. I'm afraid 0, I'm not sure if 0 will work or not. That's why I have to look at the program again. But if you put 1s in here, it might work and it might not. I'm not sure, but 2 will work for sure. And what it'll do is it'll put it sort of in a position. And then here's what happens. Originally, all the sprites were like in this big cube here, like this. They're all located randomly in this big cube. But now what I've done is I made the cube only one big. It's only in one spot. So you're only making one sprite anyway. So the sprite is going to be generated in that little cube, which is 1 by 1 by 1 or 2 by 2 by 2. It's going to be generated there. So virtually you have a handle on the sprite itself. Then you can say, if I move this entire system over to here, that one sprite will move over to there. If you move the entire system, wherever you move the system, that sprite will go because it's right in the middle of the system. Before, what would happen is, if you moved the entire system, then all of the sprites would go this way, and all the sprites, wherever you told them to go, they would go. The whole field would go. In other words, you couldn't control any one of them. But if you only make one, you have control over it. You think of it like an individual, but you're actually treating it like it's a whole field of individuals. It's just one sprite, that's all. And so what that does for you is, it allows you to make objects as sprites rather than as objects. Now here's the difference. If you make an object, like a plane for example, you make a plane, and then you slap a texture on it that's got a little picture of a sprite, okay? You've actually created an object which, when you go over here, it's going to be flat. You're going to see it's flat. It's not going to face you all the time. If you do the exact same thing by making a sprite and put the same picture on it, what will happen is, when you go over here, it keeps, no matter where you go, it keeps facing you. So they act differently. They act very differently. And by the way, if you make a plane, try to make 50,000 planes and watch what happens. Your computer won't do it. It won't handle it. It'll stop, right away. So the thing is, you can't make 50,000 planes with sprites printed on it, with images printed on them, but you can make 50,000 sprites with images on them because they're made completely differently. Okay, it's the way that thing's implemented. So that's the reason why the sprites are very handy. You can do things that you can't do with regular. Now, I use sprites for all kinds of stuff. For example, I use it to make flames. You can make flames with sprites. You have the thing flickering. You have different flames. I have, like for example, in one of the programs we have here today, I made 3 different sprites. I made a sprite system of maybe it's red, green, and blue. And one of them was a big system that moved like this. It swung in that direction. And then another one swung over the z-axis, and another one swung over the x-axis. So there was 3, red, green, and blue, I think. And what they do is they swing over these different axes, and you can kind of see them moving around, and they look pretty cool. They actually look pretty interesting. But it shows you that you can take 3 sprite systems, the whole system of them, and put them together. And they don't interact with each other, and you can see all these things going on. So there's a lot of ways of using them, but I mean, I can imagine, I've used them for lots of things, but there is still some limitations. Let me tell you what they are, because they're important to know. Normally, when you make a sprite, an individual sprite, you want to process its entire lifespan. It creates, it does something, it dies. So for example, suppose you had a water fountain like this, a fountain like that, and the water's coming out of the top. You can generate a sprite, and you can have it go in any direction you want, and you can also have a formula telling what gravity's doing to it. So that sprite, through its entire lifetime, as it flips through, can go like that. And the other sprite can go like this, and another one can go like that. They're randomly generated, and they're all attracted by gravity, so they're pulled back down. And then if you get 50,000 of those, you have a very obvious waterfall of some kind. But you see, in order to do that, you have to apply a mathematical equation to each one of these guys here, each one of them. That's not possible with what we're doing. If you come back next semester to look at the site, if you ever do, I'll have a way of doing that, but I haven't got it set yet to go. But that's a kind of a handy thing, because there's a lot of stuff, water hoses, waterfalls, bouncing water. Water is a good one to use with sprites. It works out really nicely. And fireworks. You can do a lot of things with sprites. So ultimately, you can do other things than you can do with this thing. But this thing here does have a lot of possibilities. I've used this method for quite a few things. So as I say, you can control one sprite, you control 50,000. That means that you have really a lot of control over the objects. See if I miss anything here. Nope. I guess I've pretty much got all of the stuff I wanted to cover on that. Let's take a look at the programs, and I'll talk through what the programs actually demonstrate. Each of the programs has some little variation in it that does something. Nothing. It's just in small. Couldn't see it. Okay. All right. It's kind of funny without the yellow, isn't it? The yellow's actually here. It's just down more. Okay. Let me start with these things here. I think this is the first one. Yeah, this is the first one. This right here tells you how to do it. you have to always have those script things in here. Let me tell you why I didn't put it here, because if I put the script thing in, the computer would see it, and it would start doing stuff I didn't want it to do, because it's HTML, it would start doing stuff. So basically what I did is, I didn't put the script part in, but you know how it works. You have to put the script thing to start with. And then you say var, and then the name of your variable, whatever it is, equals new, and then the sprites, and the number of sprites there are, the maximum x, which was 500 here, maximum y, and maximum z, and then the sprite size, and that's the one that goes between somewhere between whatever 1 and 64. And that's it. Let's just run this program, see what it looks like. So this is the first one, and its only purpose is just to throw some sprites out there, just to make them go. And what happened, I wanted to paint. I made a black square, and I drew this snowflake in it, or whatever it is, star, whatever it is in there. And then I brought it to X and view, and I made transparent all the black stuff, and all that was left was a little white snowflake. And that's it right here. That's it coming down. Now, if you look at the snowflakes coming down, sometimes you can see right through them, right? You can see right through everything around them. And other times, what happens is this little black block covers some of them. That's because of the painter's algorithm. That's the problem. These guys are not in the original position they were created in. Now they've gone to the front, and they're in the wrong position. So when the thing tries to use the painter's algorithm using back to front, it has a reverse problem. Because once it prints something that's supposed to be transparent as solid, when you print something else, it's going to go right on top of it. It's going to look crazy. It won't look right. So basically, that's the problem. That's what happens. But you can see it doesn't affect very much. Unless you have some specific thing you're doing, it doesn't affect a great deal. So let's go to a different picture, though, and see what it does with the color ones. Now, these right here, all this is it's the very same thing, except in the first one, I had it rotating over the x-axis like this. So all the sprites were rotating like that. And they always keep facing you. They never face away from you. And in the second one, the red rotates over like the y-axis, and the other one over the z-axis, and the third one's over the x-axis. So in other words, the three sprite systems are rotating over different axes, and it just gives you this funny clustered up feeling of what they're doing. I only did that at this point was to show you how many you could have. I think there's like 1,000 each of these guys, or so, maybe even more. There's quite a few sprites in here. And you can, by the way, you can back up. The arrows work, you can back up, or you can go into them. It's kind of cool when you go into them because they're all around you. And if you look left or right, once you're in there, if you look left or right or anything, like they're all around you, you're completely embedded in them. So you see, this is like sort of something that would be handy for, I don't know, some kind of a game, some kind of an artsy-fartsy game or something. So you can see, right, you can't see through this one. Some of them you can see, some of them you can't, but that black thing sort of seems to be there. Because it was originally back here, now it's been moved up front by rotating, it's in the wrong position. Okay, there are people who claim that they can fix that, but I'll tell you what they have to do is, they have to reorder every single sprite where it's going to be drawn, and boy, that's a lot of sorting, it's a lot of work, so it would slow this down enormously, so it's really not worth doing. Okay, so that's one thing you can do. Let's go here for, yeah, this is the winter night one. This one's kind of cool. What I did was I used snowflakes, 3 or 4 snowflakes that had kind of a design to them, right? And they were like artsy, and so the trouble is they glittered and stuff. And it didn't look too bad. It was kind of, it was kind of sort of okay. But then I discovered that when I went to, wrong one. I went to the other one right here, which is just little white blobs. It looked a lot better. So the better snowflake you made, the worse I think this looks better, don't you? I mean, it just looks more like snowflakes falling. And the other one didn't look like that. Now, what's going on here is actually very simple. What I have is, take a look at it here, I'll look at the background, see how this is done. Basically, that's a background picture. That means any sprite in front of it will be properly shown, because it is the backmost object, and when you draw things in front of it, that backmost object is going to be solid, and the other things are going to be by the painter's algorithm. They're going to be in front of it. That's going to happen no matter what. In other words, the background object is always going to be a good background for sprites, because it's not going to show the transparency. They only show them between each other. And by the way, I did the same what I told you about before. When I made these snowflakes, I made the transparency right up against them, so it was very, very close. There's not a lot of big blocks around it, and that helped quite a bit. I want to show you the program now. This one may have something in it worth looking at. I don't know if that's readable. I'm going to bring it up a little bit because I hate to get a situation where people can't read this stuff. Okay, as you can see, nothing here is different than normal. It's all the same old stuff. The only thing is when you draw a sprite, now this is the background plane right here, so that's the picture of the town. That's all it is. That's what my sign is right here. But the next group of things right here, these flakes right here, I had two kinds of flakes, I believe. Let me see if I had three kinds of flakes. I made three different little, like different shapes. They're just white blobs, but they're sort of different. And what I said to the first one was rotate over the x-axis, which means it's going to rotate like this. They're all the flakes are going to rotate like that. And I'm in the front, so obviously they're going to rotate. They're going to come down. I'm going to see them coming down. But as they start to go to the bottom, they start to slide back that way, which is perfect. It looks like a little, snowflakes don't quite fall straight down. They sort of do a little wind thing or something. Well, this gave the impression that instead of falling down, they were sort of gradually sort of falling that way, which was perfect. So all the flakes are going like this. And I did the same with this one right here. I rotated the second one over the x-axis and the third one over the x-axis. So I got three groups of sprites, three different pictures on these. Each one of them has, let's see how many they make. I made 5,000 of each. So it's 5,000 of each kind of snowflake, and they're rotating down all over the x-axis, and that's the effect it gives. Is when they come over here, they look like that, like this. And by the way, the reason why the ones in the back look like they're slower, as you can imagine what happened, is because of natural perspective. They're drawn further back, so they're calculated to be where they would be if they were moving. They would move slower. No, it's thinking the distance, move shorter distances and things in the foreground, just by the perspective calculation. So these things are all in actual positions, X, Y, Z positions. So therefore, the ones in the back are falling just like a regular snowflake. They're falling at the same speed, but because they're so far back, it looks slower. So in other words, it gives you the impression that you've got planes of flakes coming down, which is really, they're all moving at the same rotational rate, but not at the same visual rate, because of the way they're designed. So those flakes are everywhere between 500 and 0. You can see all the flakes coming in, coming down. And as I said, I made 15,000 of them. So there's quite a few flakes here. A lot of them are off to the right, and a lot of them are behind us too. I didn't know. In fact, let me do that. See if I can move this thing. Yes, I can. You're going to see more flakes because you're going to see more of them coming down. See, it's getting thicker, a little bit thicker. See, I'm backing off from the scene, and what I'm basically doing is getting back to see all the sprites that were falling behind me. And now what you can see right here is the top of the sprite wheel. You can see the very highest ones, the 500s. It doesn't go any higher than that. See, it's rotating over towards us. So we're reaching the top of the thing up there. Anyway, that's how it looks. Let's go to the next one here. This one right here is where I push it right to the limit. This is like the 50,000 deal. That cube right there, look how fast it rotates when I just have a normal cube rotation. Let's go into it. When you go into this guy, you begin to get the true feeling of how many dots there are in this thing. There are 50,000. Actually, it won't show you until they're all drawn. So there you are, you're in the thing now. And as you can see, if you rotate to the right or left, you're inside of it. Now the reason why you don't see more, there are 50,000 here, but the reason why you might not see more is because the random generator may hit the same number many times. It probably will. So what will happen is you'll end up with some dots that are almost other dots, and it's all one dot, basically. It doesn't show you anything. So there's a problem with that. But other than that, you do have 50,000 dots here. And as you can see, it runs, once the thing is constructed, it takes a couple of seconds for it to construct. So sometimes you get a white screen. I think what would be good to do with you can see the black thing, so you can see all of the problems that come with it. But as a distance, you don't see that stuff. It doesn't show it to you. You basically just see glittering, a bunch of glittering dots. You could actually make objects out of it if you wanted. You could make, cylinders or anything you want, but it would be a little bit of work. I don't think with our system, it would be easy to do. You'd have to think it through. It'd be too hard. But as I say, next semester you'll get some more stuff there. This is the single sprite one here. The single sprite is just that 8 UAV. That's all it is. That's one sprite. And it's kind of moving around against the background of Blaine Lake down there, picture of Blaine Lake. And It had a buzz to it, but I pulled the audio out because it would drive you crazy. Those things make a lot of noise. So I put that in fake, but I get rid of it. If you look at this thing, I don't know if you can see it at all. Let me blow it up a little bit and see if you can see this or not. What? Come on. There it is. If you look at this thing, you can see the propeller rotating. See it rotating? Can you see it rotating? You can see it's got a little bit of rotation there. It doesn't really have any rotation at all. What's happening is pixels, as it goes by some pixels behind it, the calculation of which pixel shows and which doesn't is irregular. So what it does is gives this weird idea that the thing is rotating. If you looked at it on the screen rather than on the wall, you'd probably see it. And it gives you the weird feeling that that propeller is rotating. It's because it's a very thin object moving through with other objects behind it, and there's a glitter on the edges of the object because it doesn't quite calculate its distinction very well. But we've always thought that was funny because it turned out. By the way, I use this as in my trig class. We did trig calculations with this guy, so it's kind of I'm used to using it. But anyway, there it is. That's a one sprite deal. Let me show you the program itself because that's the most important part. I think this program, if I'm not mistaken. Okay. Oh. It's giving me a hard time. One more try. Oh, that's got to get small. That's why. Okay. There we go. Bring it back again. Okay. This program right here, I want to look at the sprite part. This is where you create it right here. I call the thing UAV. I created sprites, and it's only one character. See, it's just one single character. And I gave it a 200 and 200 leeway. I didn't have to do that. That could have been brought down to 10 or 1 or 2 or whatever. 2. I don't know about 1. I'm not sure if you put 1s in all these or not. You might be able to. But that would bring it to one spot, just the 0 position. And that would be good. If it was in the middle, that would be good. Because then when you move the system, now let me talk about what I'm talking about there. See this thing right here says particle system? The UAV is the name of the entire system of all the sprites you have. We only happen to have one, but it's the whole system. So when you take that particle system, you position it, if you move it this way or that way, or wherever you move it, the whole system moves. In this case right here, I moved the Z out to 200, which means I took that one single sprite that I had and I moved it 200 towards me. So now what it does is it's rotating. If you look at it, I made it rotate around the y-axis. So the thing is now rotating around the y-axis. It's 200 out. That's what's going on. It's not 200 out. It's rotating around that axis. It's 200 out. And that's actually, that's the reason why I think originally I gave it a 200 by 200 leeway in the x and y direction. So it would be away from its middle. So it would rotate around its middle of the system. So you see there's two things going on here. There's each sprite, which has a character of its own, which you can't get to really, except in this case right here where you fake it and pretend that the whole field is just one character. And then there's talking about the whole system, which this program we're using does. It talks about the entire particle system. What it does is, if you create UAV, that is the whole system, no matter how many sprites are in it. And but under normal conditions, you can actually, each sprite can be addressed. By the way, you can also, there's also a way, which I didn't write either, of putting animations on sprites. So each sprite can have an animation on it of some kind too. You can do that. As I say, I hate to keep saying this to you, but next semester that'll all be there, but it's just a little bit of a problem for me to get it done. And that's pretty much the sprite situation. I think you'll figure out ways of using it once you try it a couple times, play with it. You'll think of something to use it for. There are some really nice. Actually, maybe I should see if I can go there. Let me go to Google. I want to go to this guy here. This guy right here. This page right here, this guy is among the best. Let me just get through this page itself. I'm going to get rid of this thing. There we go. I don't know. 3JS examples right there. This guy has hundreds of programs. I mean, he's got hundreds of programs literally and they do really marvelous things. I mean, they're very, very beautiful. They're in 3JS, and it uses the same code we use, except that what he's done is he has, instead of having like we have about 6 lines of code to get everything going, he has about a few hundred lines, because he wants to make sure that it works for every single thing he does. So he brings in a whole bunch of stuff we don't bring in. But that's because he's writing very complex programs. Let me see if I can find one that's quite, some of his programs are just amazingly nice looking. Let me go to Mesh Move and try that one. That one. Let's go to Shader. Shaders. Like this one right here, for example. That cool? Essentially, what it is he not only puts a different texture on the thing, but he also distorts the thing at the same time. And it looks it's randomly distorted, and it's very, I mean, you can do stuff like this by, it isn't much harder than what we're doing, by the way. It's not like we're doing something that's so much easier. But we just don't have the tools in there to do what he's doing. But, you know, that could happen. We could do that. Get rid of this. We got another one. Some of these things are quite amazing. Here's a sprite one, particle engine. This is the same stuff we're doing, except that in this case, let me bring it down for people that are home. As you can see, what he does is, as he creates the particles, he creates them different colors and bursts, and then he has them change color as they go along. And we can do that because each sprite could be calculated if we wanted to do that. It's just ours aren't. Ours are just one. You get one thing. That's all you get. He's also got this thing up here so you can actually change stuff. You can push buttons and it creates different combinations of things. There's the rain one there. He likes the rain one, yeah. I'm going to increase it a little bit if I can. I guess I can't. That's as much rain as we can get. But you can see we can make rain. We can do that. We can make rain, snow, and all that kind of stuff. But he does it somewhat differently, but as I say, we'd have to have a lot of, here's one of his video to texture. This is something that we already do. This is something that we do in our, already we put videos on our and if it's a video, that's sound to it too. You put the audio running, it would run fine.
What brings you to the land of the gatekeeper?
No scary people. I think they're from the trigonometry class or something. The 3D world, the wraparound world. These bubbles right here. We could do that. This is a very special kind of animation, by the way. I'm glad I'm showing this to you because this is interesting. Most animations, the way the world is designed is that the world is considered a bunch of little objects, and the objects are moved around in 3D graphics. These bubbles here are different. They're made in an entirely different way. If you were at the moon and you were at the Earth, and you wanted to know where is the point at which you would go to where you would be attracted equally by the Earth as by the moon. Okay, there is a point. Okay, it's called the Lagrange point. If you go up on that plane, you go up a little bit, you find out that the Lagrange point actually is a surface. It's a surface of some kind. It's the point where both objects are attracting you at the same power. Okay. Well, what these guys are is these are Lagrange points. That's what they are. They have two objects. Okay, and they say if you're attracted to this one and this one's attracting you, draw the points that are equally attracted to both objects. And it turns out that these cool spheres. And what happens is those spheres are designed like that. And when two objects get closer to each other, the Lagrange points change because they bump into each other, and all of a sudden now you get a peanut. Rather than two balls, they hit together and they form a peanut because the amount of pressure that point is getting from gravity is equal to what it was. Each one of them was out here and out here. So basically what happens is it's a different form of graphics, and it's kind of an interesting, weird thought to it. But that's something we don't do, but it's in the world of graphics, and it's very interesting. It's different than what we normally do, mathematically. This one right here, I think this moves, if I'm not mistaken. No, it doesn't. All this is it's a wave. It's a wave that starts, if you drop something in the water, it makes waves that go out like that. All that is a wave. And what they've done is when they said it's above a certain point, make it red. When it's in the middle, make it green. When it's in the bottom, make it blue. So that's a mathematical calculation of a wave. That's all it really is. Voxels, another different universe. This is really weird. Let me see if I have to get this down, if I get it down here. Come on, how do you? I can't turn it down. What are they doing? There you sort of see it, but you can't see it very good. In the world of voxels, again, that's a different world. What happens is, instead of having dots that are linked together by triangles, which is what all our surfaces are made like, voxels are little blocks, X, Y, Z blocks, and they stack them on top of each other to make everything out of those voxels. And I'll tell you why there's an advantage to voxels in games. If you take a character and you put a bunch of points and you make a character, if you blow that character up, what do you do with it? You'd have to make little pieces. You have to redraw little pieces of it and so to be complete and everything. If you make something out of voxels, when you blow it up, you just simply take all the voxels and throw them aside. It looks like an explosion. They all just fall apart. So in other words, if you're going to make a wall that's going to be broken down or something that's going to blow up, voxels is the way to go because you make them out of little cubes, and when the thing breaks, it can break any place. Wherever you hit it, it can break apart, and you can pull all the pieces together in different chunks. You can't do that with a regular graphics block, because when you hit it, you have to redraw new blocks, and where are they going to be? This one already has the blocks there. When you blow it up, those blocks are just moved to a new position, and it makes it so much easier to do. That's what they call a voxel. It's like, instead of a pixel, which is just one in an X, Y, Z direction, a voxel is a three-dimensional pixel. That's what they think of it like, okay? So that's not a bad idea either. If you go to this guy's name is Spimkowski. He's got hundreds of these programs, and they're very, very beautiful. They got all kinds of stuff. I'm sure you'd be impressed by them. And he's writing in JavaScript, or not Java, JavaScript. And he's writing it just pretty much the way we write. It's just that he's got a couple more tools than we have. That's what quite a few more tools that he's using. Anyway, my thought is, as I constantly narrate at you, is that eventually this stuff is on its way in. But in 2013, just a few years ago, a lot of the stuff we're doing now was not doable. And now there's a lot of stuff we're doing now because what's happened now is the computer's graphics board is now running the graphics. That means that the web pages now have the power of the computer graphics board to make 3D stuff they didn't have before. And it's only a matter of time before somebody starts making 3D web pages. That's imminent. In fact, I'm surprised nobody is. I've looked out, I haven't seen anybody, except these guys who are playing with it, but I haven't seen anybody doing it seriously. But I do believe that is the immediate future of this business. And so if I had any advice to you, if you're in any field related to that, I would advise you strongly to, if you go into HTML or anything, to get into it. I think that's about it. I think this course has done its job. I hope it was worth something to you. I don't know what you were looking for when you came in, other than just 3 credits. But maybe that's all you want. But if you have any other interests or anything, they have an online evaluation form. I have no idea what it looks like, and I'm going to put a notice up on our page. I have an evaluation I asked for myself. It just asks you to just give me your opinions of stuff. Got that, you guys? It just give me your opinions of even good, bad, or indifferent, or even something. If you like something, if you don't like something, I can get rid of it. I mean, I can change this course as much as I want. If it's really bad, I'll deal with it. If there's something good, you think it should be expanded, tell me that too, and that way I can make the course better for the next generation of students. That's it. This course is over, except for the final, and that'll be December 15th, is it? 1 to 3 in this room. And I'll bring lots of crying towels and stuff. The exam's not that bad, really. The exam's not that bad. I can even tell you basically what it is. It's 50 questions, or 49, I think, and 2 points apiece. Some of them are true and false. They simply say things like this. Here's a bunch of instructions from our programs, and here's a bunch of questions. If I want to do this, which one of these would you use? I mean, it's almost obvious just by reading if you've done any programming here. And in this, as I say, there's multiple choice, true or false, a couple of program lines to write in. You have to say, this is what the program line says, if you want to do something else, what do you do to do that? No, it's, all I'm trying to do is get you to be able to take programs that there are and change what you need to change to make it do what you want to do. And that's the essence of the whole thing. And hopefully the final, the final shows you that. So, unless you want to talk about anything, I've talked myself out. Nope. Who hasn't got their project done yet? Anybody?
Wait, done or hasn't done?
You still working on it?
Yeah, I just need help with it.
Okay,
We
project.
have one last thing that I.
Okay, anybody else? You guys got your projects? Yeah.
That's the one.
Yeah.
I just
right.
did it.
I know yours is going. Anyway, so that's it. I'll be around for for a while. Whatever you want to talk about. Let's do it. Get your projects in.